So module 11 is about the security in the network design. So by the end of this module, you should be able to incorporate security into the design of a network, describe the function and the feature of the various network security device, explain how authentication, authorization, and accounting work together to have a secure network, and compare the authentication technology here. Okay, you have the network hardening by design. So by default, remember that one of the security policy you have to follow is that you charge no one here. Right? That is a zero charge security model. That means everything in the network is considered untrustworthy here until it is proven otherwise here. And router, switches, and server, and every other device on the network are at risk from the malware, malicious user, intruder, bots, and unintentional error, misconfiguration, or failure here. And security must be implemented in many redundant layers here that permit a network and protect the resources from every angle. So remember that when we do the security, you have to work in the layer and you have to diversify it. Okay, so the router and the switch security configuration is some of the basic router and the switch configuration here. Remember the router, right? The router, you have the two major functions of the router. The first one is to interconnect the network together, and the second one is to always tell what is the best way to reach the destination here. Right? So basically, if you know the process of the router, right? You know the process of the router, and you know the process of encapsulation and encapsulation here. So whenever the router receives, right? Whenever the router receives the packet here, whenever the router receives the packet here, the first thing it have to examine the packet here and determine the destination. Right? So see, when you send it to the layer 3 of the router, right? In the layer 3 of the router, you have the source IP address and you have the destination IP address. So when you send it to the router at the layer 3, router checks both of the destination of the source and destination IP address here. So based on destination IP address, it maintains the routing table, right? You know that you have the routing table here. And in the routing table, we have the matching between the IP address and the exit interface, right? You can see that exit interface here. So think about it. Tells you that if you want to go to the network 192.168.1.0/24, you have to send it out from 0/0 here. Right. Okay, that is the process of the router. So whenever it receives the packet, it always examines the packets and it always takes the decision, right, to tell you how to forward it to the destination here based on routing table here. Right? And by the default, if you don't restrict anything, the router just receive it, right? Examine the destination IP address here, look it up in the routing table, and forward it to the exit interface here. And if you want to enhance the security of the router, you can work with the access control list here, access control list or ACL here. By the router need to decline forwarding a certain packet. It's not always right. So for the access list here, it acts as a filter to instruct the router to permit or deny. Remember that whenever we work with the access list, you have the permit or deny. That permit, you allow it to go through, deny, you stop it here. Right? And traffic according to one of the more of following variable here. The first one here, the network layer protocol. The router able to check if the packet here belong to the IP or ICMP here, right? And it also able to check for the transport layer protocol also to check if it is a TCP or IP or UDP here. And it check about the source IP address, check about the destination IP address, and it check about the port number here. So basically, you see all of this thing here to tell you that if you work with the access list here, you're able to permit or deny based on the layer 3 and layer 4 information. Right? You know that in the layer 3, you have information about source and destination IP address. Right? And in the layer 4, you have information about with type protocol. It can be UDP or can be TCP, or it tell you about the port number. So, right? So based on port number, you can tell it can be the web service HTTP port number 80 here, or it can be email, so port number 25 here. So basically, when you work the access list, you're able to implement the security by apply a filter here. And what is a filter? Filter is a permit or deny. And what can you do with the permit and deny? You can permit or deny based on IP address and based on port number here. Right? Okay, so each time here, so if you apply the access list to the Tran router, each time router receives the packet, the first thing around, you have to examine the packet and there's the following here, refer to the access list. It can be permit or denied, right? And if it's a deny, it drops the packet. If it denies a characteristic match, and it matches the permit, it forwards the packet. If it match the permit characteristics match here. And remember one thing is it's very important here. If the packet doesn't match any criteria in the packet, it dropped. It is implicit deny rule. So think about this one here. In the access list, in the access list, in the access list, you have a list of the criteria. They call it the criteria here, right? Where? Yeah, criteria here. So it can be the, say we have a deny 192.168.1.10, right? And the second one here, the permit 192.168.10.20 here. And now you see when you receive it, right? When the router receive it here, it only work in the order from the top to the bottom here. So we'll see if you look, if the destination IP address here 192.168.1.10.10, deny it, drop it. And if you see that the destination here 192.168.10.20, permit it, forward it. So what happened here? If you have the destination of the 170.10.10.10, what do you think? You only have the two criteria here in the access list, but the IP address here is not matching with this one, not matching with this one.
Wouldn't it get dropped under the implicit deny rule?
It is implicit deny here. As you see, this definition here is not in the criteria list. It understands that it will drop this one. That is the rule of the access list. That's the rule of access list here. And in the most router, each interface must be assigned as separate access list. And different access list may be associated with the inbound and outbound traffic. So you can apply it. So you think about this one here. You have router here. You can apply it on the incoming traffic, or you can apply it on the outgoing traffic. But remember, for each of the incoming traffic, you're only able to do for one access list only. Okay, so here's a way it works with the access list here. Remember, in the case of access list, you have a list of criteria here. You have a list of criteria, and it's only work from the top to the bottom here. Right? And whenever match, that do it here. So see, you check right. Whenever you got the incoming packet here, you check the first criteria here. You check the first criteria here. If permit, forward it. If deny, drop it. So now it moved to the second one. That is the thing about this one here. You have the IP address 192.168.1.10. Right? Check the first criteria. Permit, forward, deny, drop. So we move to the second criteria here. Again, check it again. Permit, forward, deny, drop, and so on. It only works in the order, in the sequential order from the top to the bottom here. And so see what happened here. Now we can see what happened here. So what happened if I have if I go to the packet here, I can check here. The first one is a deny. The second one also deny, and the third one is deny, and the fourth one here, you see, the fourth one here, that is implicit deny. Implicit deny, that means if it doesn't match any criteria here, In the case that doesn't met any criteria here, you should implicit deny. You got it? Now, so for that reason here, in every access list, you only need at least one permit. That's the thing you have to remember, that you have to need at least one permit. Otherwise, you can understand that it deny everything.
If you cannot get 3 permits, then you will be denied.
Sorry?
If you cannot get 3 permits, then you will be denied.
Now it's up to you. It totally is up to you, right? It only works in the order. It always in the order. So you have the first, the second, and the third here. So what happened here? It checks the first one, right? It checks the first one. It's not matching anything here. You see, it's not matching anything, right? So see, if you check the first criteria not matching, move to the second criteria. Now check the second criteria not matching, move to the third one. Right? So the third one here, right? In the third one, you're not matching. That means you implicitly deny here. Now even that you have the matching, you have the implicit deny. That's why you only need one permit, at least one permit in the access list. Otherwise, it drop everything. Here. Okay, so here's the access list work, right? Yeah, the access list command is used to assign a statement to already install access list here, and the command must identify the access list and include the permit or deny. Right? So in the access list, always permit or deny here. Right? So here is example. Here's the example to permit the ICMP traffic from any IP address or the network to any IP address to the network here. You have the command access list, and this is the name of the command. You permit here. ICMP, that is a ping message here. JSON message here. Any, that means allow everyone. Right? And this one here, if you want to specify to specific host here, you can use here the command permit. Right? You specify it's a TCP. That is a layer 4, right? It's a layer 4 here, and you specify here host and host here. That means you permit TCP traffic from the 222 to the 555 here. The more statement or tag a router must scan the more time, right? It only have to do it from the top to the bottom here, and in the order from the top to the bottom here. Okay, so let me show you some of a very simple access list for this one. Here. All right. Yes. So here, what is it? Let me show you something here. Okay, so you see in the access list here, this one is access list number 100 here. You can take whatever number, 110 or 150 here. So you can see on this one here is that is work in the order. Right? You see, this is the first criteria. Right? This is the second one here. So for this actually you only have the 2 criteria here. So what happened here? Right? The first one is the access list here. Deny what? Deny ICMP. That means the ping message here. The ping message. So deny what? Deny everything ping from the specific host here to the specific host here. And the second one now is the second one is it? Access list here permit ICMP any. That means any other one you permit it. It only deny from this guy to this guy only, but any other one you permit. But remember here, if you do not have this one here, if you do not have this one, that means you deny everyone. You see, this one deny, and the next one is implicit deny. Remember that actually the next one here, that means you deny. And you can understand that. You only for every access list here, you only have the last criteria. It is a deny any. You got it or not? Deny any. Right. So we check here. Check in the order from the top to the bottom here. Check the first one. If the source is 172.31.1.10 and the destination 192.168.1.100, drop it. If not, move to the second one. Permit anyone. Go through. But not here. You see, if you don't have this one here, you move to the deny any. That means you deny everyone. Yes. Okay. So we can see it here. So when you define the access list, remember that you have to apply it to the specific interface. That's why you see. That's why. Sorry. That's why you see when I define the access list here, I have to apply it to the specific interface. Yeah. For this one here, you see, I have to go to the interface G0/0 here, and I put the command IP access group 100. So when I define 100 here, and I apply it the incoming traffic here. So basically here, this one is G0/1. This one is G0/1. So it come to the router, and now the router I have the two criteria, right? The first one here, deny what? Deny ICMP. ICMP from when? Anyone? From this one here. This one I put is 172.31.1.10. Deny from the 172.31.1.10 to the 192.168.1.100. That means anything from this computer to this computer will be dropped, but it doesn't impact to any other ping. So if you want to ping from this one, or this one, or this one, it's okay. And you can check it here. You can check it here. So now I ping. Yeah, so see, I'm able to print the 10, right? 10 is this computer here. 20 is okay. Maybe I change the yes, 20 is okay. Now 30. I have to check if I confirm the demand here or not. Okay, so let's see. Sorry, 30. Correct. 30. Oh, people be way changing. So that's all. Okay. So now 30 work, right? Now see what happened here if I ping to the 100. I see definition or unreachable. Right? And the reason is because I apply the access list here. I apply the access list number 100 and I specify that anything from this guy to this guy, you are not able to do it. You are not able to do it from anything from this guy to this guy. But you see, permit here, any other one, you allow it. And that's why I see I'm able to ping from here to here to here to here, but not this guy. Make sense?
Yeah.
And the control plane here refer to the decision-making layer for connected network device. You can use the control plane policy that is more powerful when you work access. You can group them together and you define the policy and when you permit it or not. It originally this one is beyond this knowledge of this class, so I don't go into detail for this one. Now for switch security, the switch security here, and remember that you learn something about router advertisement when you work with the IPv6, when you work with the IPv6 already. So in the case of IPv6, if you want to configure for the dynamic IP routing, you want to configure the dynamic IPv6 IP address routing here for the router, for the computer, right? So the first one here, if you want to get it dynamic IPv6 address, you send it out the router solicitation message. Router solicitation message, that means you tell everyone, you tell routers that I am new member here, and I need to get the address of IPv6. And from that one, the router will answer with you is the router advertisement here. The router advertisement, that means you have the private information, and you have private LAN 64, and you have default gateway information, and you have to generate the 64-bit here from your own in order to generate the IPv6 address here. But you have problem with this one here. What happened here when you send it out, right? When you send it out, the router solicitation here, actually you send it to every router on the network. You send it to every router. Right? So what happened here? It's this guy, it is a bad guy. It's a bad guy here. He pretends that he is a router, he is your gateway, right? So he send back to you the router advertisement here. Actually, information in the router advertisement here is not correct. So instead of sending to the default gateway and send to the internet here, now the bad guy send it to you, right? So now see, instead of sending to the router here, now you send it to him, right? And now him forward it to the default gateway, and you forward it to the internet. It works as kind of the man in the middle here, right? Intercept. He intercept everything between you and the default gateway. Right? So in that case here, the code is a malicious router advertisement here. It can be used to misconfigure the network client. So when we give you the wrong information, you might have the wrong default gateway information. You might have the wrong DNS information. He can intervene many things here. And in that case, if you want to recheck it, you can configure on the Cisco switch using the RA command here. Now you make sure that only the one you allow it able to send out the router advertisement, but not any other one. Okay, so you see, you can configure it here, right? You know, when you are a network administrator here, you know for sure. You only have the router here, right? Only have an interface and connect to the router, and this one is the legitimate network router, and you chat it. And any other one here, any other port here, you configure the router advertisement graph here. So if he try to send it to you, it will be blocked. It's not the legitimate guy here. Okay, that is for the IPv6, and for the IPv4, you got the IP address from the DHCP server. You got if you want to get the dynamic IP address, you got it from DHCP server here. And if you know the process of the DHCP server, this DHCP server works. DHCP here work everything with the DORA. DORA here. That means you have the discover. You have discover message. You have offer message. And you have the request message. And you have acknowledgement message here. So here's the thing: you got the cell phone or the iPad. You just step in the Starbucks coffee, right? And if you want to access to the internet, you need to get the IP address from the DHCP server. But you see, when you just step in, you have no idea who is the DHCP server. That's why you send out broadcast message. You just send out broadcast message here to everyone, and you raise a question. I want the IP address, and who is the DHCP server here? So basically, this one is the legitimate guy, right? And he can check here. He maintain information about the IP address pool, and he can check some of them available and some of them not. Right? He can take one is available, and he gives the offer to you. Basically, it works perfectly. But what happened here? What happened if this guy is a bad guy? This one is a bad guy. The bad guy. So instead of the offer you the correct information about the IP address, about the default gateway, about the DNS information, he gives you the wrong information here. That is something they call it's a rogue IP. DHCP server here. That means it's not the legitimate one here. So here's the thing. That is a case of the rogue DHCP here, and you got the DHCP spoofing attack. So see, instead of you got the information correctly from the DHCP server here, now this guy pretend he's the DHCP server, right? And he give you information, wrong information here. So see, instead of sending to the default gateway, correct default gateway, Now you send it to him, and he forward it to the correct default gateway. You can work as a man in the middle again. Right? So in that kind, they call it is a DHCP spoofing attack. DHCP spoofing attack here. One of the other attack for the DCP is the starvation here. Starvation. So basically, you see, when you send, right, when you send it to the DCP server, right, when you send it to the DHCP server here, DHCP server maintains the IP address pool. IP address pool here. IP address pool. You have the limited number of the IP address pool, maybe the 200 or 500 or 1000. Right? So here's the thing. Whenever you got the request, right, you check the IP address available, you gave it to him, you get it to him, and you gave it to him here. Now, that is the bad guy. He tried to send many requests. He tried to send many requests, right? And every time he generates the fake MAC address here, right? So one time A, other time B, and C, and D, and E. So we see he generates the fake MAC address, and every time he requests the IP address, and you hit him, you get it to him, right? So very soon, you run out of available address. That's why they call it starvation attacking. Right? So see, when this guy here, he got all the IP address. Now, if you are the real guy, you want to access it, you have no way to access. You got it because all of them already run out here. Right? So in order to mitigate and in order to mitigate the problem in the DHCP spoofing and DHCP starvation here, right? You have to configure for what port you charted and what port you not charted here. So basically here in the router, in the switch here, right? So in the switch here, you know for sure that port here connect to the DHCP server. So you configure charted here, right? And you know for sure that this port here connect to the another switch, and another switch you charted here. But any other one configured uncharted here. Right? That is a rule of at the beginning. You have to uncharted everyone for sure. Right? And now you know this charted, you charted here, but this one uncharted here. So now think about this one. This guy here, he pretend he is a DHCP server. Right? And you see when you have the computer here, you send the discover message, right? And now this guy here, he pretend he is a DHCP server. He send it back to you, the offer here, right? But you see, when you send to the switch understand that this guy has no way to be the DHCP server. That's why you drop it here, right? So it can prevent the problem of the DHCP spoofing here, right? So what happened here? Now this guy, if he work with starvation here. Starvation, right? Starvation, that means he generates the fake MAC address here. A, request one address, B, C, and D here. Right? So in the case of starvation, you can restrict the limit here. So think about that. For 1 second, he only able to send out the 5 requests only. Cannot more than that. Right? You see, if you come back to this one here, you can come back to this one. For one, the thing about this at one time here. At one time, right? Or during the 1 second, he can send it 1,000 or 10,000 requests to the DHCP server, to the switch, right? To the switch to the DHCP server here. So in the case, if you want to prevent problem of starvation here, you can recheck it. So at one time, at the 1 second here, he cannot send more than 5 requests or 10 requests. Got it? Let's ask.
Yeah, it makes sense to me. I'm now realizing how important switches can be to security.
Yeah, it's really great. Okay, so one of problem with the ARP also. ARP, what is the ARP? You remember when you use the ARP?
Address resolution protocol?
Yes, and why do you need to use ARP? Why do we need to use ARP?
Because switch do not have the IP address.
Yes. So you use ARP in the case you know the IP address, but you don't know the MAC address. Right? You don't know the MAC address, and you know that in the process of encapsulation here, whenever you want to send it out, you have to process encapsulation. Right? So we have to put the IP address destination here, IP here, and the source destination here. That's IP. Also, you have to put the source destination MAC address and the source MAC address here. So you see, in order to send it from the source to destination, you need both of the source and destination IP address, and you need both of the source and destination MAC address here. Right? And of course, MAC address, it depends. Sometimes it is a real destination, or sometimes it's a default gateway. You know that, right? So in case that you know the MAC address, but you do not know the MAC address, right? So you use ARP here. You use ARP here. ARP, it is address resolution protocol. You send it out to everyone. Again, send it out to everyone. You have the high chance of someone he pretend he's a destination here. Right? So instead of send it to the correct MAC address, he send you to the fake MAC address here. Right? So we think about this one here. If you look on this one, right? If you look on the MAC address table, you know that in order to maintain the matching between the IP address and the MAC address table, you have the MAC address table cache in each computer. Right? So first thing here, you look on the cache, and if you don't have the insert cache, you send it out the ARP here. So here you see at the beginning, here you have the matching. Sorry, you have the matching the number 10. It is gateway information here, and it matching with AAA is correct. And the number 12 here matching with the CCC here, the correct. And so this one here, number 11 here matching with BBB here is correct, and number 12 here matching with the CCC here. This one is correct here. But what happened here? Happened here? This guy here is send out the ARP. He can actively send out the ARP message here, and he tell you that if you want to reaching to the 10.0.0.1, please send it to the C here. Please send it to the C here. And also, if you want to send this guy also, if you want to send it to the 10.0.0.11, please send it to the C here. So now we see what happened here. This guy, both of the guy updated, right? Both of the guy updated here. So now see, instead of the send it to the default gateway with the correct information, it's AAA here. Now you change it to the C. And also this guy also, instead of sending to the 11 here with the MAC address, it's the correct information to B. Now he changed it to the C. So what happened here? This guy, right? If he want to send it to the default gateway, actually he send it to this guy here. Right? You see, you have CCCC here, right? He send it to this guy here. So now this guy here, he forward it to the default gateway. Right? And now if the default gateway reply you, again, check it. You want to send it 11 here. So he send it to the CCCC here. Right? And again, this one here, forward it to this one. That again, it is a man in the middle here. And it works transparently. You have no idea actually from the communication from the computer to the router, you have someone intercept between you and the default gateway here. Okay, so how can you prevent it? Actually, in order to prevent it, you have to working with the die here. Die is a dynamic ARP inspection. So in the die, it maintains the matching. In the die, maintains the matching between the IP address, and you have the port number here. Right? So see what happened here when this guy, right? When he said at the beginning, right? When you connect it to the switch, and it's a port number F0/2 here. So switch store information here. So I know that 192 here, 168.1.10 come from the F0/2 here. Come from the 02 here. So now what happened here? If this guy here, he pretend it's someone, right? If this guy here pretend it's someone is not correct here, he can check the IP address here, and he knows that that is not the real one here, and he said drop it here. Okay, so in the case, in the some of the network, it works as a proxy server. So proxy server, it is the one that intermediary between the external. You see, whenever you want to have the connection between the external and internal network, right? You sometimes you work as a proxy server, and it's the main purpose. It is a screening here, screening all of the incoming and the outgoing traffic. So see, instead of directly communication between the internal network and the external network, you only have to go through the proxy server, and proxy server is the one who screening the traffic here. And the proxy server manages security at the application layer, as they can appear at the internal network server to the outside world, but also filter the device on the internet network here. And also you have the reverse proxy also. It provides a service to the internet client from the server on its own network here. Okay, so you can see about this one here. That is a proxy here, right? So see, for any communication in and out here, for any communication in and out, you instead of go directly, right? Instead of going directly to the, sorry, let me clear it here. So instead of going directly to the communication between the external and internal here, anytime if you want to access into the internal network, you have to send here to the proxy server, right? And screening it, and after that he send it to the destination here. And also if you want to go out, the first request you have to send it to the proxy server, and proxy server forward it to the internal network here. So it's screening every information. It kind of representative here. And in the case of proxy server, you have the two types of the proxy server. The first one is the forward, and the second one the reverse here. The forward here, you see the forward is a they put as they set it between the internal network, right? Between the internal network and the internet here, internal network and internet. So you see when so sorry, my mistake here. You make if you put it between the internet and the public network here. So you see whenever you go to the proxy server and you go to internet and you go to the original server here, and this one is the reverse proxy. You put it between the private network here and the internet here, private network and the internet here. So see, if you want to access it from the outside, right, it's the first thing you have to go to the reverse proxy server, and you can forward it to the server here.
Which is most secure? Which is most secure?
It depends. It depends on the what traffic flow here. It depends on the what traffic flow. Because for this one, you see, it's the one you can come from. Sorry. Yeah, it totally depends on the flow of the traffic.
Communication and makes the request for us, thus the name proxy when we talk about a proxy server. Our client workstation would communicate to a proxy, maybe request a website. The proxy then goes to the website, receives the response from that website, and then sends that information back to the client device. We are never talking directly to that end website. The proxy is sitting in the middle, and it's performing all of those communications. We commonly see proxy servers used for something like control or security. Maybe you need to log in to gain access to the internet. You're really logging into a proxy to provide that access control. Proxies are also good for caching, so the proxy can grab information from the internet, and the second person who needs that information can grab it from that local cache. You also see this when you're doing URL filtering or content scanning, because the proxy can make the request, receive the response, and then examine that information before sending it to the client. So if the client unknowingly is downloading a file with malware, it can be scanned at the proxy, and the proxy can throw that out before it ever reaches the end station. In the example I just gave, we commonly see a forward proxy being used to perform that function. This is usually where we'd have an internal network, and the internal network has, in this case, a user and the proxy that's on the inside of our network and something that is controlled by our network team or our security team. The end user makes the request to the internet. It hits the proxy. The proxy then makes the request directly out to the internet and gets the response. And then once the proxy is sure that everything is okay, it sends that information down to the user. Now let's take that scenario and reverse it. Instead, now you are on the internet and you need to access a web server that's located on the inside of an organization. So here we are out on the internet and we're going to communicate with a reverse proxy. This reverse proxy takes all of the communications from the internet, examines it, makes sure there's nothing that would be attacking the web server, sends the request down to the web server. The web server responds, but of course it's not responding back to you, it's responding back to the proxy. And then the proxy, of course, is communicating back to you on the internet. So it's the same as the original proxy we were looking at, our forward proxy, except now we've turned it around and made it a reverse proxy. Another type of proxy you might run into is an open proxy. We commonly
Okay, so now move to the firewall. Firewall. So remember the firewall, you heard a lot about the firewall. The firewall, it can be the software or the hardware. Software, you can think about the Windows firewall, right? See, you can probably it's a Windows firewall here. But normally for the corporate network or the large network, they have dedicated firewall, hardware firewall here. So it's a firewall, it might be placed internally or residing between the two interconnected private network here. And more commonly, a firewall is placed between the private network and the public network. It's a network-based firewall, right? So you can screening every incoming traffic from the external network, from the internet, and also you can screening every traffic from the internal network come to the external network here. Okay, and the simplest form of the firewall is a packet filtering firewall. It is a network device or application that examines the header of every packet here. Every packet that you can check header of the what is the destination IP address, what is the source IP address here, and then it refers to the access list here to determine it need to block the traffic, permit or deny here. So basically, you see that you can have normally the most common one is for the corporate network. You lay down the firewall between the internet and the private network here. Right? So we see that if everything coming from the internet, if you want to access to private network, you have to go through firewall screening process here. Also, if you want to go out, you also have the screening process here. Okay, so it can check both of the incoming and outgoing with the firewall here. And the common criteria by which the packet filtering the firewall might be accept or deny traffic include the source and destination IP address, the source and destination port flag set in the TCP header. You see that when you learn about the transport layer, right? When you learn about transport layer here, think about you have the TCP here in the case that you want to set up the connection with the TCP. Remember that TCP is a connection-oriented protocol. Before you send it, you have to handshake between the source and destination, right? And in the TCP here, you have many header. You can have the header of the FIN request here, right? Acknowledgement here, or reset here. So when you work with the firewall, it's able to check in the flag set in the TCP header also. Right? Also, it filter based on the UDP or the ICMP protocol and packet status as the first packet in the new data stream and subsequent packet here, and the packet status is the inbound or the outbound from the private network here. So basically, you see the difference between the access list, right? You see the access list also, access list and the firewall here. So you see the access list and the firewall, it work quite the same, right? So access list also check the destination IP address, check the source IP address, check the port here, right? Check the right. But see, in the access list here, if you think about this one here, if you have the private network here, you have the private. And you have the internet here. Internet here. So basically, the access list, the code is stateless. Stateless inspection. And for the firewall, the code is stateful inspection. Okay, so basically here for the access list, right? You have the router here, and you apply the access list here. So basically, you know that for the access list, it's only permit or deny only. Permit or deny. And if you want to restrict everything from the internal network here, from the internet, go to the private network, you just drop it here. So what happened here? What happened if you have the computer here, right? And you want to initiate the connection from private network to the internet? It's okay. But what happened if he reply to you? You drop it. You drop it in the case of access list here. That's why the code is stated. You do not keep track of everything. But in the case of stateful here, you know that this is a section here. It's a section. So think about that number 1. And he reply here. It's a section number 2. And he knows that even that coming from the internal network, but actually this is a reply from the section number 1. So you allow it here. So that is the difference between the access list and the firewall here. Access list is blindly permit or deny only. He cannot keep track of the full status of the transaction here. But for the firewall, he keep track of the full status. That's why they call it stateful inspection here. Okay. And the port blocking, you also prevent the connection and to the transmission completion through the block port. And you have the optional firewall function includes here. You can do some encryption in the firewall. So user authentication. What is the username and password? Centralized management. You have E0 establishment, logging, auditing capability, protect the internet LAN address here. It monitors packet. That is stateful here. You have the stateful here. Now let's see. Okay, so the rule is quite the same. The rule, the firewall rule is quite the same with the access list. But remember, the main difference between the access list and the firewall, access list it is static, but the firewall it is stateful here. And of course, when you work with a firewall rule, you have more control. You can more control here to filter or secure traffic and enter, exit, and traverse the network here. And through here, you can check at the port, protocol, and IP address here. Okay, so basically, the rule it works the same with the access list. Also, you have the list of the rule, and you will work on the order here. Okay, and sometimes you have to take action to troubleshoot the firewall. I think about you apply the security policy too strict, right? That means you cannot access to many service here. So in that case, you have to manually to adjust the policy here. If you set it too open, it very harm to the network. But if you set it too very strict here, sometimes you are not able to access to the service. Okay, the most common cause of the firewall failure is firewall misconfiguration and configuration. Not so strict here. If you set it so strict, sometimes it limits the performance here. It prevents the authorized user from the transmitting and receiving the necessary data, but also do not so open. So we have to balance between the so open and so strict here. I think you should watch the video here. Firewall here.
Let's start our conversation of firewalls with a firewall that's very close to us. And by that, I mean it's physically close to us. It's generally running on the computing device that we're using. These are personal firewalls or host-based firewalls, and they are software that's running on your system. Many host-based firewalls are included with the operating system. They are simply part of the OS that you're using, although you can also purchase personal firewalls from many third parties. These host-based firewalls are able to stop unauthorized traffic because they understand what the state of communication is to other devices. We call these stateful firewalls because of that. When you talk to another device, you're coming from your IP address and a port number and communicating to an IP address and a port number on another device. The firewall recognizes this and keeps track of all of the different connections you've made and over what port numbers. If any traffic comes into your device that is not on this list, it's not part of the current state, then that information is automatically dropped by the firewall. Since these host-based firewalls are running on our operating system, they're aware of what applications you're using, and so they can also be configured to allow or disallow certain applications from communicating through your system. A very common host-based firewall is the Windows firewall, and it can filter information by application, by port number, by IP address, and by many other tuples as well. Here's some of the screenshots from the Windows firewall. You've got a main screen that allows you to turn on or turn off the Windows firewall. There are also exceptions that you can create. If a certain program should be operating through the firewall, but it's not working for some reason, you can enable or disable that. Notice by the program name itself, because it's application aware, you can define a TCP or UDP port number and then tell the firewall to either allow or deny that traffic passing through this firewall. We might also have firewalls that are on our network, that are outside of our operating system and connected to our network infrastructure itself. These firewalls are network-based firewalls, and they are designed to filter information based on OSI Layer 4 or the TCP or UDP port numbers that might be going through your network. Some firewalls are also application aware. They know what type of applications are going across the wire, and they can allow or disallow access based on the application data itself. Many firewalls also have VPN tunneling capabilities built in, where you can connect different sites up by their firewalls and encrypt all of the information between the firewalls. That way, if you need to communicate to a site that's across the internet, you can send encrypted data over the public internet and decrypt it on the firewall so that it can be used inside of your organization. Some firewalls are configured as proxies, where you make a request to the firewall, and then the firewall makes its own request on your behalf to the internet. It then examines the results that it gets back, and if there's no malware or anything dangerous inside of that response, it sends that response down to you. So it acts as the middleman or the proxy for all of your network communication. Many firewalls are also configured as Layer 3 devices, so they'll provide routing functionality between the inside of our network and the outside of our network. This is a good way to have a central device that sits between you and the internet that provides routing, network address translation, and security. Today's modern firewalls are application aware. They know everything about the data that's flowing through the network.
You see that also one the difference between the firewall and the access list. Access list only work with the layer 3 and layer 4, but the firewall also work with the application layer here. So you see, you can filter based on the World Wide Web address, or that thing belongs to the application.
You may see these referred to as application layer gateways, stateful multi-layer inspection devices, deep packet inspection, next generation firewalls. What they're doing effectively is decoding every bit of traffic that's passing through the connection. It's looking and analyzing, understanding exactly the type of application that's flowing through, and then making a security decision about whether that application is allowed or denied through the network. Because your firewall is now application aware, it can make decisions not just on port number, but on the application, or in some cases, the way the application is working. You might
So we see work on the application also, and the web address also. But basically for the access list, you only know what is the port number or something.
allow or disallow Microsoft SQL Server or Twitter or YouTube, or even subsets of that application. For example, you may be able to view Twitter but not post to Twitter because your application-aware firewall knows exactly the differences between those two. Many of today's firewalls also include some type of intrusion prevention system as well, and having that application-aware visibility can even hone its signature detection down to very specific application vulnerabilities. And as we mentioned before, our host-based firewalls already know what applications you're using, so you can set some very granular controls inside of a host-based firewall. In your small office or home office, you probably also have a firewall. These firewalls are usually smaller devices that don't have the same throughput requirements as the larger devices in your enterprise, but they are still providing you with a number of valuable security functions. They can be a wireless access point, they'll provide the routing for your connection, they'll of course be firewalling all of this data, and there might also be enhanced content filters inside of these devices as well. What you may not get with these firewalls are things like dynamic routing protocol support or the ability to access the device remotely. These are more advanced capabilities that you would find in an enterprise firewall, but may not be available in these smaller home office or small office firewalls. These days, we try to put a lot of functionality into single devices, and you
Okay, so we also have the intrusion detection system and intrusion prevention system also. So in the case of the normally you can apply it in the network here. So we see normally you do it on the router firewall, and after that you have the intrusion prevention system here, and you have the intrusion detection system here. So for the detection, it cannot intervene. It only trigger the alarm and it tell you something wrong. Right? So think about, you observe here, this guy here. You observe that we have a lot of the sync request. Think about that. Right? A lot of sync request is the case of the DDoS attack here. DDoS attack, right? So you see a lot of the request sync. You can trigger the alarm. So from that you can take the action here. Right? That is a IDS here. IDS is the intrusion detection alarm. But in the case of IPS, IP here is the prevention. That means he can intercept it. He can look into the packet, and he can take the action here. Right. Okay, and the IDS can remember the IDS here only detect and the log suspicious activity. But for the prevention system here. Yeah, prevention system, it reacts to the suspicious activity when it alerts, and you can take the action here, right? And detect the threat and prevent the traffic from the flowing to the network based on originating the network, the IP threat here. So we can have the network-based intrusion prevention, can protect the entire network, and you can have the host-based intrusion prevention, protect the specific host here. So we see you have the intrusion prevention system here. You can set it, right? So we can set it based on the segment. So each of the separate network, you can have to separate the network intrusion system here.
Many security professionals incorporate a network-based intrusion detection system, or IDS, or a network-based intrusion prevention system, or IPS, on their networks. This is designed to watch traffic going through the network, and if this device identifies an exploit against an operating system, it identifies a buffer overflow, a database injection, a cross-site script, it's either going to inform you that that happened if you're using an IDS, or block the traffic if you're using an IPS. And that is the most significant difference between an IDS and an IPS. With an intrusion detection system, you'll simply receive an alarm or an alert, whereas an intrusion prevention system has the capability to stop that intrusion before it gets onto your network. There are many different ways to engineer your IPS into your network. One way is to configure it as a passive monitoring device. This means that the IPS will receive a copy of the traffic and be able to then make a decision on what to do once it's received that information. Because it is acting as a passive monitor, it's obviously not sitting in the middle of the communication and able to block traffic. You might have traffic going from one device to another, and as it's passing through the switch, a copy is sent to the IPS. If something is identified in the middle of this communication, you may be able to have the IPS inform you that it saw the intrusion, but obviously the traffic has already passed through your network to the other device. The only possibility that you might have when you're in a passive mode is to be able to send what's called an out-of-band response. It's an out-of-band response because the IPS is not part of the traffic flow. It's sitting out of the band of the communication. If traffic does traverse the network and the IPS receives a copy and determines that that traffic is malicious, it can send a TCP reset frame to both the source of the communication and the destination. This TCP reset will close the session between these two devices, and they will no longer be able to send traffic to each other unless they set up another traffic flow between the two devices. This is obviously done after the fact, and you're hoping that you're able to stop this communication before much of the malicious data is able to traverse the network. This also has very limited capabilities if there are protocols other than TCP. For example, UDP doesn't allow to perform a reset. If this is a UDP communication, there's no way to stop this communication if you're sitting in an out-of-band mode. If a security professional is looking for more control over these traffic flows, then they'll probably configure their IPS for inline monitoring. All traffic then is going to pass through the IPS, and the IPS is going to make a decision on whether that traffic is allowed through the network or not. Because the IPS is sitting in line, the response to any type of malicious traffic will be to drop this immediately at the IPS and not allow it to traverse the network. There are many different ways to look for malicious traffic going through your IPS, and not all IPSs will use all of these methods. One of the most
Okay, so we still have a cloud security technology. So far, you know that you have some category of the cloud technology. You have some service of the cloud technology here. So you have infrastructure as a service, you have a platform as a service, and you have the service and a software as a service here. And the first one is on-premises. That means it's not cloud. You think about on-premises. That means you have the network and you have the data center for your own. You buy your own server, own router, and all of the network infrastructure here. So basically, for on-premises here, everything is your responsibility. You have to control everything. You have to control the temperature. You have to control everything about infrastructure and the software. Everything is the network here. And in the case of infrastructure as a software, you run the infrastructure network from the thing about Amazon, right, or the Microsoft here. So basically here, for the physical infrastructure, it's not your responsibility. It belongs to the Amazon. Think about that. If you work with AWS here, Amazon Web Service here, right? So that if you work with the infrastructure as a service, you run everything with the physical infrastructure about the server, about the router, right? But on top of that, you are the one who responsible for that, right? You have to install the operating system. You have to install the application on top of that. So you see, only the infrastructure it is belong to the cloud responsibility here, cloud provider here. But anything about the operating system, the network control, application, right? Identity management, endpoint, data, and security, it's your responsibility here. So in the case of platform, at a service, right? You have to run out the operating system, infrastructure, and you have to run out the operating system also. But most on top of that, also application and something you also have to handle. And for the software as a service here, software as a service, you see you have everything from the hardware and even the application. Right? Everything belongs to the cloud provider, and on top of that, you have to handle for the job, the security here. Okay. So we have to understand about the share responsibility model here. It depends on what type of service. Infrastructure, only the network infrastructure. It belongs to the cloud provider, but on top of that, everything belongs to you. What thing? Which device can be used to increase the network performance by caching the website?
Proxy server.
Yeah, right. You have to catching it and you screening it before it. Okay, you can forward it. If not, you stop it here. Okay, now you move to the authentication, authorization, and accounting, and they call sometimes they call it triple A here. Triple A here. So that for the simple network, right? So think about if you have, if you have a simple network here, you have the router and you have the switch here. You have the router, the switch, and from that you can connect it to multiple computer here, and you connect to the router, and you go to the internet here. That is normally the home network here. It's very simple, right? So yeah, so you can configure on every single computer here, right? On every single computer, you can configure what is a username and password. It's very simple. It's only about 10 computer here. And for the switch also, if you want to access to the switch to do some configuration, you are able to set the username and password for the switch, and so for the router. It's very simple, right? You only have the handful of the device. Very easy for you to manually configure the username and the password with the authentication here, right? Or authorization. So, but in the case you have to work in the corporate network. Right? You have a corporate network. You have many router, many switch, and many computer here. You cannot manually go to every single computer config for the username and password here. It takes a lot of time and a lot of management activity here, and it's not security. It's not security at all. So in that case here is a corporate network. You will have the dedicated. You will have a dedicated AAA server. You have dedicated AAA server, and in the AAA server, it maintains the database about the username and password, about the authorization. Authorization, that means to which level you can do it. Some of you only have some specific command you're able to do it, but some other one he can do a lot of the intervention in the network here. Right? And the first one here is authentication. Authentication, that means to verify who you are. Right? You have to enter the username and password here. The second one, authorization. Authorization, that means to which level. Someone is only at the level 1, but someone's at level 10. He can do with many intervention here, but this one only is a monitoring. Right? And the third one, it is accounting. Accounting, that means it keeps track of everything. What time you log in, what time you log out, and what command you did it on that one. So that normally for the corporate network here, they maintain a dedicated AAA server. Right? So see what happened here. Every time he log in the computer, right? He route it to the AAA. Now see, verify username or correct password or not. Every time you log in the router route it to the AAA. Every time you route to the switch verify if username and password correct in the AAA here or not. And also we see if you are the user, you can sit from this computer or from this computer or from this router. It doesn't matter. It providing that you have to enter the correct username and password, and you got it from the AAA server. And it is a centralized device and dedicated device and control the database of all of the device on the network. Okay, so you have authentication. That means who you are. Authorization, how much you can spend. You can think about credit card here. And accounting, what do you spend on it? Keep track of everything here. So time and love and what they do, what you do for this one here. Okay, so authentication is that mean to verify who you are. You have say what is your username and password here. Right? So basically for the authentication, you can do both of the local authentication or remote. Remote, that means you have to access it to the AAA server. Right? But what happened here? If you lost the connection to the AAA server, you are not able to log in. Right? So in that case, you have to use a combination of both of the local authentication and the remote authentication also. Okay, so basically, let's see, if you have the username and password stored locally, you have some of the advantage and disadvantage here. Low security. Could you see? You configure it on the computer here. So once the people know the username and password, everyone able to access it. Everyone able to access it. So you see, if your son he knows the password, he can access it. Can access it here. But if you set it from the local here, whenever you move to the new computer, he has not able to. So basically, you see, you can use the name and password from this computer, on this computer, on this one computer, right? You can do it for multiple computers, only not specific to specific computer. Right? And with the local authentication here, every computer on the network is responsible for security on its own resources. If you locally configure, but if you work with a AAA server, the administrator is the one who handles it. Okay, and the network authentication and login restriction. So if you work with AAA, right? It can do with the authentication, and he can verify the username and password here. Also, it's not only this one, right? Also, additional authentication restriction here. Like what time of the day, right? So he can specify that if you work on the morning shift, so you're only able to log in from the 8 a.m. to the 2 p.m. But after that, you have no way to log in. Right? That is the time of the day here. And total time log on. So we specify that one time you only have the 2 hours to log in. Right? And the source address, you know for sure what it come from, right? And you have the unsuccessful login that time. So if try to have the 3 attempt within the 1 minute, right? The password will be locked. Right? Also, it works on the geographic location. So make sure that you are here in the Bloomington in order to access into the network here. Authorization is that is a, you can think about how much you can pay here. Sorry, how much you can spend in the credit card here. Authorization is to which level you can intervene in the network here. The user access to the network resources fall into the one of the 2 category: privilege or right to execute, install, uninstall. Normally, it is administrator here, right? He has the right to do everything on the network here, right? Or some of you only have the permission to read or modify some very simple one here. Okay, so the most popular authorization method is the roles-based access control. With role-based access control, the network administrator assigns the privilege and permission necessary for the user from zero. The duty that depend. It depends on the role on the company here. Right? So if you think about you as the HR, you work in the HR office, you're able to access to the every file from the HR here. But if you are a student, you have no way to access it here. Accounting is that means it keeps track of everything. What time you log in, what time you log out, what comment you do, what action you do. Right? So accounting also by maintain it, very helpful in the case of billing, right? How much you have to pay in the case of troubleshooting, right? What action you do. Okay, so I think you should watch the video here.
You want to be an IT pro, so you must have all of these tools.
Being able to log in and gain access to resources is one of the most important parts of anyone's network. In this video, we'll look at AAA, which is authorization, authentication, and accounting. If you're logging into the network, you're connecting to a VPN, or you're gaining access to the command line of a switch, you're probably using a AAA framework. The first step in using this AAA framework is first identifying yourself. We usually use a username to do this, but there are many different ways that you could use to identify who you are. At that point, we need to provide some other type of authentication, some way that we can really prove that we are who we say we are. This is usually a password or one of a number of different authentication factors. Once the authentication process is approved, you can then gain access to the resources that would be appropriate for your particular username. If you're logging in as an administrator, you'll have different authorization than someone who's logging in with a guest account. And with the last A of accounting, we're tracking all of this information. We know when you logged in, we know what data was sent back and forth, we may be tracking the different resources that you're gaining access to, and we're determining when the logout time might be. Here's how this AAA framework operates for someone who might be authenticating to a VPN concentrator. So from your client workstation, you would communicate across the network and log in to that concentrator. In this case, it's also a firewall. Because we've not provided any authentication yet to log into this VPN, our username and authentication information will be passed to a AAA server that's usually somewhere else inside of your network. The AAA server will authenticate the information you've provided, and if those credentials match, you're approved to gain access to internal resources. Now that this authentication has been approved, the VPN concentrator will allow traffic to flow back and forth from your client to the rest of the network. In our previous example, we could have chosen a number of different protocols to provide the authentication between the VPN concentrator and the AAA server. One of the most popular protocols is Radius. This stands for Remote Authentication Dial-In User Service. And you'll find Radius services available on a number of different operating systems, and we use it for many different purposes on our networks, not just the dial-in that's in the Radius name, but it can be used to authenticate anyone who happens to be on your network. For example, we can centralize all of your authentication using Radius. So if you're logging into a router or switch or a firewall, you can use your same credentials to log into a server, to log into the remote VPN access, or to log into your wireless network with 802.1x. One of the reasons Radius has become so popular is that you can find Radius services for almost any operating system. So if you're running Windows or Linux or Mac OS X, you can find a Radius service that will run on those operating systems and many others. An alternative to Radius would be TACACS. This is the Terminal Access Controller Access Control System. This is another remote authentication protocol very similar to Radius, but it was created to provide access to dial-up lines on the older ARPANET. Cisco took this TACACS configuration and created a customized version of it for Cisco devices called Extended TACACS or XTACACS. This extended a number of the features in TACACS to include additional accounting and auditing functions. These days, if you're using TACACS to provide authentication, you're probably using TACACS Plus. This is the latest version of TACACS, and it's not backwards compatible with any of those other versions. Although many people associate TACACS with Cisco, you can find TACACS Plus services for many operating systems that work across many different services. If you're managing a group of switches or routers and you're using TACACS or Radius to provide that authentication, you know that you have to provide a username and password each time you log in to a separate device. But on today's networks, we want to log in one time and then automatically have access to all of the resources associated with our login. To enable that functionality, we use Kerberos. Kerberos is a network authentication protocol where you can authenticate one time and then you're trusted by the entire system. Kerberos can also provide mutual authentication where you would authenticate to the server and the server would also authenticate to you. Kerberos also takes advantage of extensive asymmetric encryption, which means it can prevent man-in-the-middle or replay attacks from occurring. Kerberos has been around for a long time. It was created at the Massachusetts Institute.
Okay, so we will also work with the directory service. We work a lot and adaptive. I think that in the window, the way help you to authentication and authorization. Cameras, just watch it. Single ones. sign on that you have to work with the two-factor authentication here. So Radius. Radius is a remote authentication dynamic user service. It's a cross-platform and open source standard. Normally, you work in the combination with the AAA here. It helps you to verify and to access to the AAA server here to verify username and password to see what is your authentication to do it and to see what is to keep track of everything with the accounting. So we see that is the way normally in the case that normally in the case you work in the case you work from the Windows desktop here. You have the Active Directory. You have Windows Server. You can think about that. In the Windows Server and in Windows Server you have the username and password there, and also we have the control information authorization. So anytime you see anytime you log in the computer, actually it sends the request into the database here, Windows Server here, and Windows Server have the database to check what is the username and password here. So it doesn't matter. It doesn't matter if you sit in this computer or another computer. It doesn't matter. But everything you log in, actually, it root it to the Windows Server here, right? So it doesn't matter that so we think that in the local network here, you can log on in any computer in the network. It doesn't matter, right? So anytime you log in, it root it to the Active Directory here in the Windows Server, and in the Windows Server verify what is the username and what's the password and what is the profile here. Profile, you have information about authorization. I think about if I log in, I'm able to change the IP address of the computer, but when you log in, you are not able to do it. That is authorization here. So it depends on the profile here. So basically, from the Windows desktop, you work with the LDAP here. LDAP is work with the Windows Server in the Active Directory. But in the case you work with the network device, so think about the switch or access point or router, it work with the Radius here. And in that you have a Radius server here. So when you look on this one here, it is not always separate server. There can be the one single physical server here, but you can break it down. One is the logical for the Radius server, and one is the Active Directory for the Windows server here. Okay, and the other one is a terminal access controller, access and control system plot here. So basically for this one here, normally this one is only work with the Cisco device before, but now it's open also. And the TACAC here differ from the Radius in that some of the thing. Guys, this one is work with the TCP, not UDP. Radius work with UDP. That's why it work faster. You know that's the difference between the TCP and UDP, right? TCP is more reliable but slower, and UDP is faster but no reliable here. And yeah, this one here, this one the proprietary protocol only work with the Cisco device only. So if you want about the neutral vendor, you have to work with the Radius. And normally it used it authenticate for the network device such as router, the switch, rather than the workstation or the server. And it's more often used for the device administration access control of the technician here. And it encrypts all information when you transmit it to the chipway for the TACAC. So if you have the information about normally you have information about the data here, and you have the header here. It encrypts all information here, but normally for the Radius, it only encryption for the header only, but not the data. What authentication protocol is optimized for the wireless client? Yes, you have Radius, right? So Radius here. Okay, I think that's all for the lecture here. Now let's see what you have for the homework. Any questions, guys? Hello?
I think I got it.
Okay, so this one work with the access list control. Seeing this one hands-on process. Okay, so here you have to complete the access list in the packages. Okay. So for PC here, you have the router, you have two switches, and you have the PC here. Okay. So for this one here, right? So for this one, you go to remember that in the access list you're only able to configure on the router only, right? Because only the router is the one who understand about the IP address here. You cannot do it on the street. That's the thing you have to remember. You cannot do it on the street. It's only able to do it on the router only. So for this one here, when you from the enable here, you go to the config terminal, right? It's where you do the configuration here, and you have the access list. Access list, that is the keyword as the number one. You can put number 2, number 3, number 4. That's number 1, right? Deny here, deny host. Host, that means you specify the IP, you specify the specific IP address here. And of course, you can configure on the range of IP address. It doesn't matter. You can do it, right? So it's not only about one specific IP address, but you can configure based on the range of IP address. So in that case, you have to put the IP address and they call, what is it? I forgot the name. It's the reverse of the subnet mark. It reverse of subnet mark. Yeah. Okay, so you see for this one, you have the access list number 1 and deny the host here, and you have to specify the IP address of the PC0. Right? So you see that is the definition of the access list, right? In the access list here, you remember that in access list here, you always have the list of criteria. You have a list of criteria here. Right? You always have a list of criteria. So this one here, you access list, you deny the host here, and you go to interface. Remember that in order to activate the access list, you have to log into the specific interface of the router. Right? And you go, so for this one here, you go to the router, you have the IP access group number 1 here, group number 1, and you apply for every incoming traffic here. That is example of the incoming traffic here.
Why would that mask? Why would that? The reverse of subnet mask, right?
Wildcard, yeah, wildcard. Yeah, wildcard, yeah, that's the name, the wildcard. Now, so what do you think? Now, you see, actually for this one, right, you go to the router and you apply the access list here. You apply the access list for this one, and you apply for this one here. And now you deny this one. You deny this one, and you deny this one. So what happened here? If you deny this one here, it applied in this one here. What do you think? Can you ping from PC0 to PC1 or not? If you deny here, you can ping from.
Zach says no.
Yeah, right. Because here, from the PC0 to PC1, actually you just route it to the switch, right? And you route on to router PC here. You have no problem, right? You have no problem here, right? Now, what happened here? If you want to ping from PC0 to the PC2 and PC0 to the PC3, what happened? You're not able to do it. Right? Because you apply for incoming traffic here. Now, that is the first question. What happened here? If you want to ping from PC1 to PC2 and PC1 to PC3 here, what do you think?
It would work.
Now, from PC1 to PC2 and from PC1 to PC3 here, what do you think? You are able to do it or not?
You should be able to do it, right?
Why no? What do you think? Now, if you look it back in the access list here, you see. If you look in the access list here, this one is denied. Right? And after that, what do you have? Implicit deny. That means deny everyone. Right? That's why here, even that you don't specify the host of PC1, PC1 have no way to ping it. PC1 have no way to ping it. Because you see, actually for this access list here, you deny everyone. Right? That's why in every access list you always need at least one permit here. But this one here, deny for this one, and after that, you see, you understand that after that it's an implicit deny for everyone here. That's why even that you don't specify the IP address of the PC1 here, PC1 have no way to ping to the PC2 and PC3 here. Make sense?
Yeah, that makes sense. I forgot about it.
Oh, it's not, it's okay. Yeah, I just want to explain you to understand the how it works exactly here. You don't have to sorry for that. Okay. Oh, that's all. Okay, so if you want to permit the computer one here, you have to put exactly here. Right, one permit. Put any here. Right, so see, if the PC 0 IP address here, check the first criteria, right? Deny. But if the PC1 here, first criteria is not matched, move to the second one. Second one, permit any here. Go through here. Oh, so this. Oh, this one is risk management. Okay, so now move to this one. This one hands-on project 11.2 here. 11.2 here. Okay, so now incorporate the DHCP snooping in the package chaser. Okay, so we have the 2 PC and one hardware here. How can you check this one? This one. Okay. So basically for this one it's very simple network here. So yeah, so basically if you look on the topology here, normally this one is very simple network. This one is very normal network. But normally for the corporate network, you have the dedicated server here at the DCSCP server at this. But for this network, you can work as a router. In the router also, you can work. You can configure it to work as a DHCP server. And the PC here and the PC here, you got the IP address from the DHCP server is the router. You can got it. You can get it here from DHCP. No, but normally it's very limited in the small network. It normally is support for in the very small network. So you understand the process of the DHCP snooping, right? So what happened here, right? So what happened is the bad guy here also is the router here, right? Think about the router, and he configured it and he plugged in the port. And he configured the DHCP server here, right? So see, instead of the sending the request to the DHCP server here, he send it to this one, right? Request here, and he reply it to you here. Right? In that case, you give you the information about the wrong. It might be the wrong default gateway, wrong DNS server here. So in order to do that, you in this class here, you understand the process of the DHCP snooping, DHCP snooping. DHCP snooping, that when someone pretend he's a DHCP server here. Right? So in that case here, in order to prevent the problem of the DHCP snooping here, you have to configure every port here. Every port here, you have to configure it uncharged port. You do not charge anyone. You do not charge this port. You do not charge this port, and you do not charge this port here. So what happened here? When you do not charge this port, right? This guy send you the offer. Send you the offer. You know that this is the bad guy. You do not accept it. That's why switch, drop it here. You only configure the charge port on the port. You know for sure it connects to the DHCP server here. And in that case, it is a router here. Make sense?
Yeah, that makes sense.
Okay. So basically for this one, it's that it works in that way. It works on that way here. Yeah, see, you have to activate the IP DHCP snooping. You have the IP DHCP snooping VLAN. VLAN 1 is by the default. By the default, everyone is the VLAN number 1. By the VLAN number 1 here. Yeah, you have to configure the IP DHCP snooping charge it. You just charge the support when you connect to the router, and in the router you configure it as the DHCP server already.
Hello. So I see that I need do some help with you on this project here. 11.1 configure the access list, access control list in the package tracer. So for this one, it's actually it tells you how to understand the idea of the access list. Access list, everything about the deny or permit here. So if you look on the topology here, you see that each interface router is one network. So it clearly show you that in this topology here, right? You have the two subnet here. To make it simple, I make it repeat here. You have the two subnet for this one here. Each interface router is one subnet. So you can think about this one. You can think about this one here. On the right, I have one network here. Each interface router is one network. And on the left also, I have another network. I have another network for this one. So if you look on this one here, the requirement here, right? You turn on the BC, turn on the port here, but you have to assign a class C here. See, you have class C IP address with a /24 subnet mask. So you know that for the class C network, you have everything in range. The first decimal is everything in range from 192 and come all over to the 239 here, right? And you have the /24. /24, that means you know that we have the 24 bit number 1 and 8 bit number 0 in the subnet mask. That's why the subnet mask is the 255.255.255.0. And of course, you have to make sure this interface on different subnet. So make sure that they are not overlap here. So to make it simple, you can think about, if you look at topology here, right? You can take the one network for this one. So we can take this one. Sorry, you can take this one. Where is this? Yeah, you can take this one on the left here. You can take it to 192, 168.1.0 network, right? That's /24. And on the right, you can take anyone in range here, 192 to the 239 here, or to make it simple, I can take it here, 192, 168.2 here, .0, right? /24. So see, they are not on the same network, right? They are separate network because this one here, 192.168.1, it is the network portion. And this one here, 192.168.2, that is the network portion. They are not the same. That's the first thing you have to understand. You have to break it down into the two different subnet. You have 192.168.1.0 for this one and 192.168.2.0 for this one here. So now, right, you just configure it. Remember that normally for the interface router, normally they take it per user address. So it's very easy for you to troubleshooting and design here. So the first usable address here is 192.168.1.1. Right? This is the network address. .0 is the network address, and .1 it is the first usable address. Of course, you have to set /24 here, right? And you can do the same with this one. You have 192. Right? You have 168. You have .2.1 for this one and /24. Okay, so now you already done with the IP address is the interface router. So every computer here on the same network, you know that every computer on the same network, they have the same default gateway, and the default gateway you got it, right? You got it from the interface here, right? So that's why you have to configure the default gateway for this PC, and you have to configure the default gateway for this PC. It is 192.168.1.1. That is the come from the interface router. And you can do the same with the PC3 and 2 here. You have to take it from this one as the default gateway. And of course, everyone is a subnet mask /24. That means 255.255.255.0 here. Right? And remember that they are on the same networks. That means you have to assign any IP address into range here. So you see for this one here, you have 192.168.1.0 is a network address, and you have 192.168.1.255 here. It's the broadcast address. Right? That's why for PC0 and PC1, you can take anyone. You can take anyone from the range from the number 2 to the 254 because number 1 already here, right? So you can take anyone in the range from the 192.168.1.254, right? So you can take anyone from the 254 you assign for this PC, and you can take the same to the PC one here. Make sure they are not the same, they are not duplicate here. So when you're done with the IP address, now you move to the access list. You know that the access list is everything about permit or deny here. You know that for the access list, you have to make sure you understand about the process of the permit or deny. So when you look on this one here, you have to actually deny the host PC0 here. Deny the host PC0, you apply it in the interface G0/0, and you apply the incoming traffic. So basically here, he just applied incoming traffic from here. So see, it's deny everything from 0, right? That's why PC0 here, you cannot ping for the PC3 and you cannot ping some for PC2, but from the PC0, you are able to ping PC1 because it go to the switch and go to PC1 here, not going to the router, right? But the thing is that, you know that for access list, you only have the implicit deny. Right? That means that's for that reason I already mentioned on the class that for every access list, you need at least one permit entry here, otherwise deny everything. So even that you say that you deny only from the PC0, but actually you have implicit deny. You also deny the PC1 and you go to the PC3 and 2 here. Right? And so in order to correct it here, so we see in order to correct it now, you have to add one more entry, the permit for PC1 here. Okay, so I think that's all. I hope you understand the requirement of this one here. Yeah. Yeah. Okay.
Yeah.
So basically for this one here, that is the purpose of this one. Okay. So the purpose of this one is that the first time, you see, nothing about it. Let me delete this one here. All right. The first time you configure the router work at the DHCP server. Yeah. The router work as the DHCP server, right? And for that reason, you can see when you do the configuration here, you configure it here. You configure the router at the DHCP server. In that, you have the network. Everything in the network address from 192.168.2.0 and the subnet mask is 255.255.255.1 and the default router or the default gateway, it is interface of the G0/0 here. Right? So for that reason, when you configure the router as a DHCP server, every other computer on the network will got automatic IP address from the DHCP server here. Right? So you think that is the real DHCP server here. Okay, and you see when you configure it, you see here. You see it here. You configure the G0/0 is 192.168.2.1. Right? So you have to take this IP address as the default gateway for every PC on the network, and for that reason, you will configure the default gateway here. So now, when you go to the every PC on the network here, you can see now you can go to the DHCP here. You automatically got it from the DHCP server, or you automatically got it from the router here. Right? It worked perfectly for this one. Right? And also this one also, it worked perfectly for this one here. All right? You see, you don't have to do anything. You got automatic IP address from the DHCP server, or actually it come from the router here. So think about this one. Even that I have one more PC here. I just need to plug in the cable. I plug in cable, and I turn it to the DHCP. Again, I got IP address automatically from the DHCP server here. You have to wait for a while. Yeah, you see, so no, not this one. Do it again. Yeah, you see, you don't have to do anything. It's very applied for the corporate network. So you have 100 or 1,000 PC. You don't have to manually configure it. You got it from the DHCP server here. All right. So now here's the thing. Because you know that one of the problem with the DHCP is it has the DHCP snooping. Right? The DHCP snooping is that, okay, so this one here, you see, if you look on the how the DHCP work is that the one you send it out the request, you send it out broadcast here. The thing is that when you send it out broadcast, you have a chance of the bad guy. He pretend he's a real DHCP server, and he give to you what is your IP address and the default gateway here. So now think about this one. You can think about this guy here, the bad guy here. The bad guy here. Okay, so see, when you configure the DHCP service on this guy, right? You have the server pool name here, right? You have the start IP address, everything from here, right? The thing is that you don't have information for the default gateway. The default information for this way, it is IP address for this guy here. So now see what you configure here, right? You configure it's 192.168.2.20 here. So in that case, you have to go to the service here. You configure the default gateway here. Okay, so now what happened here? This guy connected to the switch here. I think I have to disable the snooping here in the switch first. Okay, so now what happened here? You can think about this one is a bad guy. He plugged it out and he delivers the DHCP service. So now see, if the PC here gets the IP address, gets the IP address here, gets the IP address. So you have the high chance you got the IP address information from the bad guy here. So he give you the wrong information about the default gateway. So when we think about this one, when we got the wrong information about the gateway, right? So instead of the send it to the correct one here, you see this is the router is the correct one, right? So instead of sending to the correct one and we send it to the internet for this one here, you can think about this one. You have the internet network here, right? So you know that whenever you want to send it to the internet, the first step you only have to send it to the default gateway, right? And the default gateway send it to the internet here. You can think about this one, the internet. All right, but now you see, you got information from the bad DHCP server. So whenever you request the IP address, he give it to you at the IP address here and the default gateway. So now you see the default gateway he configured here is 192.168.1.20 here, right? So now you see, if you get the information from the bad DHCP server here, so instead of sending to the correct default gateway, you just send it to the default gateway. It is 192.168.1.20 here, right? And again, this guy here, he can forward it to the real gateway and forward it to the internet here. So this guy here, you see, he worked exactly in the case of man in the middle here, right? You send it to him forward it to the default gateway and send it to the internet. That is the problem of the DHCP snooping here. He pretend he's the real one here, and he give you the wrong information about the default gateway, or sometimes give you the wrong information about DNS information. So see, now to make it clear here, right? To make it simple here, so I just let's see, I just close the interface here. So now when I close the interface, what do we have information for this guy here? You see? No, not this one. Yes. Oh, the default gateway you have not configured yet. Why? Yeah, so why 192.168 here. .2, sorry, .2.20. .2.20 for this one. You save it. So now what happened here? I go to this one, right? I got the IP address again. Now we see, instead of the correct one here, instead of correct one 192.168.2.1, now I got the default gateway. It's the wrong information about default gateway. The default gateway here is 192.168.2.20. That is this guy here, right? So now see, every time you want to send it, to the internet here, the first step you send it to the bad guy. Now he can see everything, right? And he just forward it to the correct one and go to the internet. It works in the case of the man in the middle here. Okay, or sometimes you see he even can see if we go to this one here, he even can for this one, you don't have DNS information here. Sorry, this one here. He can even modify for DNS server, right? So instead of the sending to the correct DNS server, he now is sending to the wrong DNS server. So instead of translate google.com to someone is correct, it's 170.1.1.10. Now you send it to the bad DNS server, right? So he can translate google.com to something about 100.100.100.100, and this is the bad side here. That is the bad one-way website here. That is the idea of the DNS snooping here. It can attack it. So in order to do that, right? In order to do that, you see, you have to activate the DHCP snooping here. Right? That's why you have to go to the street here. You have to go to the street. You have put IP DHCP snooping here. And you have IP DHCP snooping, and have VLAN here. Right now we all have the traffic VLAN number 1. Right? Okay, so when you apply the DHCP snooping in the street, right? So remember that you only chart the port where you connect to the real DHCP server here. So if you look on the topology here, the G0/1 is the one who connected to the real DHCP server, right? Every other one is not supposed to be the DHCP server here. So now let me turn this one on first. So for that reason here, right, when you configure the DHCP here, you have to make sure that you only charted port connected to the real DHCP server. For in the topology here, it is the one who connected to the router, right? So you see that is G0/1. That's why when you configure it, you have to make sure you have to go to the correct one. You have interface G0/1 here. Sorry. And you have the IP DHCP here, right? And you have snooping, and you have chat port here, right? So you see when it show run here, see you will have the DHCP snooping, right? DHCP snooping VLAN number 1, and if you look on this one, that one is only the port you charted. That means you only accept the IP address delivered from the port, this port only. So when you think this guy here, he send it, right? He send it to you. It's not charted. You drop it. So PC cannot get the IP address from the bad guy here. So now see what you have for this one here. Now see, you come back, right? You come back here. You got the correct default information here. 192.168.2.1. You got it from this guy. Right? Never ever got it from this guy anymore. So now you can think about if I shut down the port here. If I shut down the port here again, right? So suppose that I only have this guy here is the DHCP server, but even that I cannot get it here. I cannot get it here. Right? You see, I only have the IP power address. It's not the real one I expect from the DHCP here. Because the thing is that when this guy delivered to you, so when it comes to the switch is not charted this guy. That's why every packet will drop. And for that reason, you do not get any IP address here.